Good to go. So first up, so there's this website called Desmos. It's basically a calculator, a graphing calculator, and you can do quite a lot in this small little thingy. So um, yeah, even before that, why do we need to do simulations? We as humans like to we are we are actually bound to simulate, to predict, to forecast, because we have this inner tendency to have a sort of a upper hand at whatever comes after us, on us. um, so we want to predict, we want to forecast, we want to tell what's going to happen, and for that we've developed the sort of language that mathematics is. And also we've developed other sorts of analytical ways. Um, yeah, that's pretty much it. But on the side of simulations and about Desmos, uh, you you can do a lot of graphing and algebraic simulations on Desmos. Um, so we're not going to go into the technicalities of how to do it, but we're just going to hover on what it is, what the things are. Yeah. So some of the interesting things that I wanted to show today, and I have them lined up here, but I'm pretty sure we're not going to cover all of them. Um, but quickly see if you can, if you see something interesting, and I'll just open it up, and I'll just try to explain it. Yeah. Okay. So this one's basically just the graph of the van der Waals equation, um, with for a real gas, that is. There's a particular solution for that. It's not so interesting. So maybe maybe I'll start with a very small thing. Yeah, this one. Perfect. So uh, you might already be knowing what a cycloid is. Huh? Now, a cycloid is what you get, the curve, when you rotate a circle, and you try to mark all the points, a particular point. So I'll try to stop this and say, so here you can see this blue dot. Yeah, you're trying to mark the locations of this point. So if I move the slider ahead, see, the point goes from here all the way to here. And keep your eye on that little blue circle. If if you mark the locations, maybe I'll try to slow it down. Yeah, if you mark the locations of this particular point, you'll get what is called a cycloid. And this curve has a lot of interesting properties, but yeah, we're not going to go much into that. Just that this Desmos site is quite powerful, and yeah, you can do things like these. Next up, I'll show something even more interesting. So basically, say you have, say, two charges kind of here, positive q charge, a negative q charge. What I've done here is, at random locations, I've tried to draw the vector for the electric field. Yeah. So the value that the electric field takes at that particular location. So it's going to be a vector of this magnitude. I could have scaled all of them down, and I could have given them an arrow, but whatever, I was lazy. And also, I've tried to make an equipotential surface here. And if you so this is basically the scaling of the vectors. So it's going to change the locations that the so you can see some regularities in the locations that I've chosen. So it's basically a locus. um, if I change the scaling, it's doing some pretty messy things. But basically, here the electric field is quite high, so the arrow is very large. And somewhere here, if there were a point where we had calculated the electric field, the arrow would have been very, very large. Yeah, yeah. So you can do all those things. On the top of it all, what I've done is I've declared some variables. I've declared a function as calculating the electric field, the vector in the x component of it, and the y component of it, depending on the distance from the origin and the angle that it makes with the x-axis. So I declared those two functions, and then I'm evaluating the values of the ex and ey at those locations, and I'm trying to make a sort of a line. And interesting on a similar line is this one. In this one, so ignore the comment, but uh, this one, I've tried to make the locations where I calculate the electric field a bit more uniform, if you could say that. Hmm? And you can see now it's starting to look quite interesting. How I've done it is a you can go into details. I can share it later on, but this is what it is. This is what simulations belong to. You can have a lot of some dynamic simulations where things are moving, like the one we saw in the cycloid. Um, but these are also pretty reasonable simulations. Um, I'm going to show last one, uh, one or two maybe. Huh. Then we'll move on to simulations in Python. Yeah. So this one is very, very interesting. So this one I borrowed from somewhere. But basically what it's doing is that is somehow doing all of the math and stopping this ball, this point from. Uh, okay. I'll show you what it does. Uh, Crap. Just a second. Hmm. Yeah. You see that? Yeah. Wait, am I audible? Somebody say something.
Yeah.
Yes, you are audible.
Huh? So this guy has come, basically defined this as a boundary, and you drop a ball from wherever you like, and it will do the physics. And, it's not a graph. It's just, yeah.
Just think like it's a wall, curved wall,
Ha,
and you
ha,
dropping a ball.
ha. It's like a ball. Just a second. I'll reload it. Maybe try dropping a ball from here. Oh, crap. The ball has disappeared to infinity.
Vishal, the parameters are set to
Yeah.
let me think. The parameters of the physics, like value of g, small g,
Hmm.
are like Earth, or
Yeah.
you're given any random
Let's see.
value.
Let's see. So this guy, Sample function bouncing equations. Okay, 20.5. So basically, we can find that out. Um, it must be somewhere here. The gravity. Okay. Ah. Okay. Perfect. I don't know. Uh, Sorry. Yeah. Hmm. Okay. Yeah. Okay. We're good to go. Just let me know if you can see this terminal right here. Okay. Perfect. Uh, so I'm going to show one last bit before we move on to Python simulations in Python, which is this one. This is not a simulation of sorts, but more of an artwork. Just playing around with the Desmos thing. Uh, so it's just this equation, very little equation. Um, so you're taking the so it's doing actually nothing. It's just plotting the points given by this equation. And I've included this less than sign because otherwise it would have been quite a little boring. See, but to color it, I've included that less than. Mm, you can change this parameter, of course. You can try to zoom in. It just gets straighter and straighter as you go inside. Yeah. So this was probably the last one. Let me see if I have anything. Probably this one. Huh. This again I borrowed from somewhere. Um. Basically, this I forgot. These are for standing waves. This is a simulation for say sound wave. Um, I'll lower the speed of this guy here, and probably you can see the standing waves. Anna? Um, we'll try changing some parameters. We'll make it more stretchy. Uh, um, so yeah, these are rare fronts. These are denser parts, and the signal is uh, then moving towards the right. Or is it? I think it just looks like it is going to the right, but it isn't. Yeah. So yeah, you can do not quite. I mean, not some very heavy lifting things on Desmos, but you can do quite a lot. You can explore things. Yeah, that's it. I'll close this one and we'll move on to an interesting stuff, interesting thing. Mm, so this very interesting simulation uh, discovered or invented, whatever you want to call it, by this guy called Conway. He died by COVID, I think. Died by COVID. He was a very prominent mathematician, um, computer scientist, more than that. So he is generally famous for this. So even if you search Conway's Game of Life on on Google, you'll see this kind of thing, the Google page itself. And basically, it's a automata, cellular automata, and some of you might have seen it already. Um, some of you might even say, "What the heck is this? What's happening?" But I'll try to explain. I'll try my best to explain this. Um, and after that, I've lined up a simulation of this same thing in Python. So basically, in this game, there is only two things, actually three things. There are cell blocks, there is a live cell, and then there are dead cells or dead spaces. The dead ones are the white ones, and the living ones are the black ones. And what are the dynamics of this game? A square that is uh, that gets occupied by three or more neighbors automatically dies. So you can imagine, so for example, this guy here, or say this guy here, he has one, two, three, four, five relatives. He's already dead, so nothing to worry about. But if it were alive, it would die. Hmm? On the other hand, the cell dies when it's too isolated. If it has less than two neighbors. So this one right here has two neighbors, so it will survive this night. But if it had only one neighbor, and this guy, if it were dead, this would also die in the next clock cycle. Hmm? And the third rule is that exactly when a cell gets exactly three neighbors, it'll pop back into life in the next clock cycle. That is. So let me see if I can find one instance of that. This one. So this one has one, two, three neighbors, the alive neighbors. So in the next clock cycle, it'll pop back into life, and so on and so forth. This game continues. Um, and an interesting thing about this game is that it's been proven that there exists no algorithm. Well, you can mathematically prove that there would not be any finite time algorithm to comment on the state of the automata. What do I mean by that? I mean basically that if you let this game continue for a while, either all cells will die, or they'll start sorry, pardon me. They'll start expanding. They'll start growing, or something in between. So it's been mathematically proven that you're not able to comment on what will happen, say an infinite number of um, steps down the line. um, you would not be able to. So it's basically Gödel's statement, that is, you cannot, it's undecidable. And that is part of what makes it very interesting. um, so I'll stop talking, I'll start showing. Yeah. First, yeah. So let me see if you can see this one. Yeah. So I made this in Python, and I made this in Pygame, a library to make games in Python. Um, so start restarting it. So every time I restart, it will have a random configuration. I'm just restarting it. It's not actually, it doesn't look quite nice. So it's not running, but I'm restarting it to a uh, suitable initial setup. Crap. Yeah, I'll start running it. Okay, and just sit back and try observing what's happening, and then we can comment on it. And that's a good place to start. So what did you observe? Some interesting observations, maybe. Um, what
What does different color
what
indicates?
is the color? What's the color doing? Why are these four blocks sitting right here? Huh. Go on. Go on.
I'm asking what does different color indicate?
That's what I am asking.
Start, it started from black and white,
Yeah,
uh, but it went purple after a while.
correct, correct. Probably I'll restart. Does anybody want to have a go at this? Um, no. Basically, yes, yes. Um,
No, there are some. This mean there are some system there are some structures which can't get affected by the uh, surroundings.
yes, yes. So
Uh,
these,
but only if the surrounding are dead cells. If
yes,
if they would be living cells, it will get affected.
yes,
Am
yes.
I wrong or right?
Yes, you're somewhat right. You're on the right thing. So the longer the a cell stays alive, the purplish or the indigo it gets. Yeah. So maybe I'll show it again. So these guys have, oh, they died. Sorry. Huh. See, they're changing color. The longer they stay, the the more indigo they get. Huh. And that's again a good place to stop. Um. So yes, any more interesting observations about this? Hmm? Brown, brown. No, these are black ones. Yeah, these are brown ones that have started to sustain themselves. So if I run it, eh, yes, correct. Huh. So yes. So these are stabilized. These have stabilized. These have stabilized. All of them have stabilized. Now I'm going to do something disturbing for them. I'll repopulate them with their enemies. Oh, yeah, you stabilized. So this is quite an interesting structure that just came up. Maybe I can try it, making this die. This died. I'll try making this one die. It all died. Okay. So this one has stabilized. But if I try disturbing it, let's see. No, nothing's happening. Maybe if I try disturbing it here, it's gone. So you can play this game for quite a bit, and you'll I mean you'll not realize how much time I've spent. Um, huh. Something again on these lines. So I made some mistake while saying out the rules. So maybe I'll try explaining it again. What's happening here? So basically, there are these cell blocks, and whenever there's say this represents a living cell, say whenever there's exactly three neighbors, a cell pops into life. So this one has one, two, three neighbors and no more of that. So in the next clock cycle, it'll spring back into life. Yeah. So we'll keep that in buffer. So we have one person to take care of, to give birth to, in a sense. Any cell that has fewer than three cells dies. Hmm? So this one has only one cell. so it will die in the next clock cycle. So we'll keep that in the buffer. So this one's going to die. This one's going to die because again it has two neighbors, and this one's going to die. This one's going to. So if I try drawing the next clock cycle, uh, we'll have something similar, but we'll then have only one cell that is alive, so which was this one, right? So this is basically the dynamics of this game. And again, if there are more than three neighbors, this cell dies again. Uh, so this one, if it were alive, in the next clock cycle, this one will die because of overcrowding, essentially. So now, what is this game tell us about undecidable things? This game is undecidable, again, which means that you cannot predict what's going to happen the infinite after infinite steps. Because of this property that the game has, it shows quite a different set of behaviors. One of which is um, chaos, of course. The other is self replication at different levels. So you can make a computer with this game which simulates this game inside of it. So who this guy is has figured out a way. Uh, Look at this carefully. To make a sort of a display. So I'll try speeding this up. So remember, these all are at the atomic, I mean, the cellular level, whatever the cellular level was. So what this guy has managed is managed to make a display, a set of cells out of the set of cells that he had, huh? And replicated the game in that. Yes, yes. So self-replication at different level. Um, अभी this does not stop here. ये चलता रहता है, keeps on going. You can have a game of life inside a game of life inside a game of life, and this guy has a 1 hour video on on simulating that. So I'll quickly speed this up. Oh, yeah. You can see again those same structures, Anna. And basically he's not done a lot of hard work. He just he has just in a sense blurred the image and looped the image onto it, but you can actually make it. It's no big deal. I mean, you just need a very big RAM. You need probably a supercomputer or something. uh, yeah, but you can make it. You can again have a level of displays which again would replicate the same thing.
But we have a display with, on which we are
Yeah,
watching.
sorry.
We already have a display on which we
Yes,
are
yes,
watching. Why to make a
yes,
display from?
yes. Inside the display, you're basically illustrating a display. No? Um, you got me there. Prasid. I mean, I'm not quite an advocate of that, but I have a few ideas lined up. It's just coming up. Yeah. So yeah, this was it for this thing, and we'll now move on to another simulation if everybody has time. So just let me know about the pace of it. Maybe I'll try making it faster. Huh? Anybody? Is the pace all right? Are we running out of time? Should I make try to make this faster? Yeah, I do. I have the whole day. Okay, so got my clue there. uh, so we'll try skipping to the end of this. Sorry. This little thing. This one he has tried to make legally. The last one. So he's only made it to two levels, two levels of abstraction, as it were. Uh, but the video just loops on itself again and again. So this is out of the way. This is again out of the way. This is also out of the way. यार अगर आप एक 10,000 I'm sorry for that. Probably yeah. This is also out of the way. I'll stop it, or else it will take some hefty space on my next. Yeah, so that was Pygame. You can simulate on Desmos, you can simulate on Python, and then you can simulate on something called as MATLAB. So it's a framework, or somebody, the people call it a programming language, but I consider it more of a framework than a language. So this is in a sense part of my coursework that I did this semester. I mean, like the second semester. Uh, we had an assignment to do, and this is part of that coursework. So here, basically, what I've done, I'll not even bother to go into the code. Um, maybe I could do that some other day. But I'll just give an overview of what is happening in this code. And unlike the Desmos one, and unlike the Conway one, I'll before explaining what's happening, I'll again show what's happening. So uh, keep processing all of it. Uh, I'm sorry. Oh, apparently nothing's happening. mm, Damn. So it happens at the exact same time. Um, Let me see inside the code. Oh, sorry. Mm, okay. Hmm. The code stop. I'll run it again. Wait, I'll try changing the parameters. I'll quickly explain what these parameters are, but before that, I want to show it one more time. You can observe that it's become slower, and it will take quite a while for this block to reach one of the ends before it dies. So it dies when it reaches one of the walls, either this wall or this wall. Hmm? And what's the story behind this? I mean, as in, what's the logic behind this? What's the underlying picture? This is what it is. Here, if you could see this. So this is part of the file that I created for submitting the project. And by the way, I got good, good scores on this. But the story is, you've got a squirrel that's on an island. This was the problem statement given to us. You've got a squirrel that's sitting on an island of size 10, 0 to 10, basically 11 spots, which it can take, 11 states that it can take. um Now you let it run either left or right. Hmm? And the chances at a particular moment in time that it will hop to the left is zero point 0.5. The chance that it'll hop to the right is again zero point 0.5. um so after a while it can either hop back, keep on living, and later on it can die. So that's that's basically p left p right is equals to 0.5. And this is basically the death menu. The squirrel can go to this spot after starting from the initial position 3, and the chances for that is 1.5, is 1 by 2, and similarly it's 1 by 2 here. Now after going here, say if it wants to jump back to 3, it will have zero point 0.5 chance again. So it will be 1 by 2 into 1 by 2, which will be 2 by 4. Oh, I'm sorry, which will be 1 by 4. Yeah, 1 by 2 into 1 by 2 is 1 by 4. But it can come here after jumping to 2 and coming back to 3, which will again be 1 by 2 into 1 by 2, that's 1 by 4. And 1 by 4 plus 1 by 4 is 2 by 4. And you can keep doing that. You can mark all the possibilities, and whenever it jumps to 0 or to 7 in this case, it will die. So the squirrel, who is fashionably named Squeaky, has this path of dying very quickly. So in 1, 2, 3 steps it will die, and the probability that it will take that path is 1 by 8. So it's quite big. It's not very small. It will die from this path, or it can come to the brink of um, death, and क्या बोलते हैं, मौत को छुके फिर किसे वापस, ये एक पे जा करके 0 पे जाने के बजाय can come back, and the fate that it has will die again.
मतलब
Here,
1 से 6 के बीच में हॉप इन करता रहेगा वो।
हाँ, ये 0 से 7 तक, और 1 से 6, मतलब हाँ, इधर पे it can hop. And I basically done that in the simulation. And you can basically imagine, if you had 10,000 यहाँ पर अगर स्क्विरल्स थी, उनको एक साथ अगर हमने प्ले का बटन दबाया, तो कोई लेफ्ट जाएगी, कोई राइट जाएगी, कोई कहीं जाएगी, कोई कहीं जाएगी।
हाँ, इसकी सिमुलेशन देखने में तब मजा आता है जब एक जो ज्यादा
हाँ,
सब्जेक्ट्स के साथ टेस्ट किया जाता है, जैसे कि
बहुत सारे
अ,
यहाँ
हाँ,
से
जब
20 निकल गए।
ट्रेनिंग होती है, एक उसकी मशीन लर्निंग में ट्रेनिंग मॉडल होता है, उसको देखने में जो मजा आता है।
हाँ, वही अभी
जैसे
वही
किसी ने
मैंने एक दूसरा सिमुलेशन किया था, उसमें मैंने यही किया हूँ। आई ट्राइड इम्प्लीमेंटिंग दिस, कि यहाँ पर स्टार्टिंग में इनिशियली मान लो कि मेरे पास 100 स्क्विरल्स हैं। यहाँ पर एक है, वो एक स्केल को रिप्रेजेंट कर रहा था, 100। तो 100 है, तो उनको अगर छोड़ दूंगा तो इधर उधर कूद के, इधर उधर कूद के, उधर उधर कूद के वो लोग फैल जाएंगे, कुछ कुछ इधर मरना शुरू कर देंगे, बहुत सारे मरना चालू कर देंगे। तो ये फोटो के बजाय मैं वो कोड चला के दिखाता हूँ। ये सबमिट करना था हमको, तो कोड लिखना पड़ा। तो ये वाला ये वाला था कि ये स्क्विरल है, ये आइलैंड है, ये है 200 साइज का, और इसने स्टार्ट किया था 100 से। ये हो सकता है कि 20 से चालू करती, 20 से चालू करने के ज्यादा चांसेस मरने का, है ना? ये 20 से या 0 से पास में है, तो मरने का इसका ज्यादा चांस है। अभी हो सकता है कि ये 180 में हो, मतलब 180 में स्टार्ट करें तो तब भी बराबर चांस है मरने का। मैंने 100 पे चालू किया था, तो 100 पे अभी इसका बहुत टाइम लगेगा। 200 का आइलैंड है, और एक एक जंप करके इसको वापस बढ़ सकता है। यहाँ आके फिर मौत को छू के वापस आ जाएगा, और फिर वापस आ जाएगा मौत को छू के, इधर जो कूदता रहेगा, बहुत टाइम लगेगा। अम, तो इसको मैं काट देता हूँ, अभी तक चल ही रहा था ये। नहीं, अभी चल गया शायद। हाँ, ठीक है। तो एक सेकंड ना, काम चल रहा है इधर यूनिवर्सिटी में। एक सेकंड।
झूठ मत बोल, तेरा प्रोडक्ट है ये।
मेरा कोई बड़ा एक सेकंड, मैं जरा बंद कर, खिड़की बंद कर रहा हूँ मैं। प्रोडक्ट नहीं कोई मेरा। एक सेकंड, अरे वीडियो ऑन कर। हाँ, देख।
आवाज कट रही थी।
हेलो।
हाँ, अब आ रही है।
एक सेकंड किसके। सॉरी भाई, प्रोफेसर का कॉल है। ये काट दिया कॉल, लो छोड़ो। क्या बोल रहा था मैं?
बहुत टाइम लगेगा उसको।
हाँ, वो उसको बढ़ना। अभी इमेजिन कर सकते हो कि जो आइलैंड है वो 2 डायमेंशनल हो जाए। ये थोड़े ग्राफ्स वगैरह मैं एनालिसिस वगैरह किया था। एक सेकंड, ये एक सेकंड में बात ही कर लेता हूँ। तो मतलब अबे सॉरी 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 सॉरी। यार सावन सावन चल रहा है,
यार
सावन
म्यूट
चल
कर
रहा है
दे।
अभी। अ, अभी एक बार मैं पूछ के मैं बताता हूँ, हाँ? कितने देर हो वहां पर? मैं तो नहीं, हम लोग अभी कुछ काम कर रहा था। तो मैं 5 मिनट में कॉल करता हूँ पूछ के, हाँ? ठीक है, ठीक है, थैंक यू। अम, क्या बोला था मैं? चिकन खाने के लिए बुला रहा था वो, मैं बोला सावन।
यार अच्छा सुन, ये क्वेश्चन तेरी यूनिवर्सिटी ने तेरे को दिया था, तो मतलब इसके पीछे एजुकेशन क्या था? मतलब एजुकेशन कह रहा हूँ क्या,
हाँ, इसके
पागल
पीछे
होगा मैं। मेन
मतलब
मोटिव क्या था? क्या सिखाना चाह रहे हैं वो लोग?
सिमुलेशन करना आना चाहिए। मतलब सिमुलेशन करना आएगा तो काफी चीजें हो सकती है। अब मान लो कि मेरे को एक एक और मतलब दूसरा प्रोजेक्ट, हमको 5 प्रोजेक्ट थे इस सेमेस्टर। तो दूसरा प्रोजेक्ट था, उसमें एक क्या बोलते हैं, अ, जो होता है इंश्योरेंस पॉलिसी, जो उसकी कंपनी इतने प्राइस में अपना इंश्योरेंस देती है, और लोगों का मरने का चांस इतना है, मतलब इतनी उम्र में मरने का चांस इतना है कि मर भी सकते हैं और पैसे लेने आ जाएंगे। अब अगर जहां पर मरना 100% है लोगों का, मतलब जैसे मान लो 99 साल का है, तो मैं क्यों पॉलिसी दूं? वो 1,000 रुपये जमा करेगा, फिर मेरे से 2 1.5 लाख 1 करोड़ जितना भी ले जाएगा, है ना? तो वो उसका प्रीमियम डिसाइड करना है, कितना प्रीमियम रखे, कितने उम्र का। तो अब ऐसे एनालिटिकली डिसाइड करना बहुत मुश्किल हो जाता है। एनालिटिकली अगर डिसाइड करो कि कितने लोग मरे, कितने लोग, मतलब कैसे कैसे करोगे? मतलब हम लोग एनालिटिकली भी सिखाया गया, मतलब ये एनालिटिकल सोल्यूशन है इस वाले का। तो हाँ, ये वाला ग्राफ मैं शायद समझा रखूँ। लेकिन एनालिटिकली सब कुछ नहीं सॉल्व कर पाते हैं, तो सिमुलेशन करना आना चाहिए। रैंडम मान लो कि जैसे पाइथन में मतलब रैंडम जो लाइब्रेरी है, उसमें से कुछ इंपोर्ट करके तुमने एक रैंडम वेरिएबल बना लिए, इधर लेफ्ट राइट जंप करा रहे, मतलब सिमुलेट कर सको, है ना। उससे फायदा हो या ना हो पता नहीं, लेकिन मजा तो आ रहा है। अ, अभी क्या बोल रहा था मैं? हाँ, 2D में हो सकता है ना आइलैंड। अगर 2D
हाँ।
में हुआ और 4 दीवारें हैं, मतलब कोई भी शेप का, अगर रेक्टेंगल हो या स्क्वायर हो या कैसे भी साइड के, चार चार आइलैंड्स की 4 वो हैं, वॉल्स नहीं, मतलब वो क्या बोलते हैं, साहिल, मतलब 4 किनारे हैं,
बाउंड्री।
बाउंड्री। तो अब क्या होगा, वो इधर उधर जंप करेगा, इधर भी जा सकता है, यहाँ पर गया तो मर जाएगा। तो एक ही ग्राफ मैंने उसमें प्लॉट किया, मतलब 2D वाला दिखा सकता हूँ, टाइम टाइम लग रहा है। तो इसमें क्या है कि अगर बीच से चालू करेगा, सी ये सिमुलेशन का, इसलिए अनस्मूथ है। वही सलाह क्या हो रहा है। हाँ, अगर बीच से चालू करेगा तो इसको मरने का एवरेज नंबर ऑफ जो स्टेप्स है वो बहुत ज्यादा लगेगा, है ना। इंटुइटिव है ये तो। अगर आसपास से चालू करेगा तो इसको मरने का नंबर ऑफ स्टेप्स मरने से पहले बहुत कम लगेंगे, है ना। मैं एक्चुअली बना के
हाँ।
दिखाता हूँ। तो ये मैंने कैसे बनाया, ये मैंने बहुत सारे पहले 10 रन करवाए, 10 मैंने स्क्विकी अलग अलग जगह से रन करवाए। हाँ, और उनका मरने का स्टेप रिकॉर्ड किया और फिर मार्क किया कि जहां से उसने चालू किया था वो वाले स्क्विकी ने कितना स्टेप लगा था उसको। मान लो कि यहाँ पर योगेश चालू किया और वो कूद काद के मर गया 5 स्टेप में, तो मैंने मार्क कर दिया यहाँ पर। मान लो कि विशाल जो समझदार है वो बीच से चालू किया और वो 50 स्टेप लगा के, लेकिन अंत में मर ही गया साला। तो उसको लगेंगे 50 स्टेप। 700 है इधर, तो 700 स्टेप लगेंगे अब। लेकिन एवरेज किया हूँ मैं, मतलब बहुत सारे विशाल दौड़ाए मैंने, बहुत सारे योगेश दौड़ाए और ऐसे करके राशिदुल भी है, फिर दीपांशी भी, सब लोग है। ऐसे करके मैं एवरेज लेता गया, एवरेज लेता गया, ऐसे एवरेज और सुधरेगा, और अगर और रन करूंगा ना तो और स्मूथ होता रहेगा। तो जैसे अगर मैं यहाँ जाऊँ सेमेस्टर 2, शिट, ये था, ये रहा। हाँ, तो मान लो कि यहाँ से मैंने 1 करोड़ स्क्विकी छोड़े। हाँ, अब वो कूदना चालू कर रहे हैं सब लोग। ये वाला सिमुलेशन, 1 करोड़ मैंने बीच में से छोड़े थे, कोई इधर गया कोई उधर गया, अब सब फैलना शुरू कर रहे हैं। अगर मैं इसको घुमाऊं, अभी अभी स्टॉप करेगा तो घुमाता हूँ। तो कई सारे लोग इधर मरना चालू कर दिए, देख रहे हो। इधर कंपाइलर, मतलब
हाँ।
पायलट होने चालू हो गए, बहुत सारे स्क्विकी मर मर के कंपाइल हो गए। और इधर वाला कम हो रहा है, नंबर ऑफ स्क्विकी कम हो रहा है, मतलब बीच में जो जिंदा है अभी तक। अ, अब ये बढ़े जा रहा है, बढ़े जा रहा है, जितने मर गए उतने बढ़े जा रहे हैं। अभी वहां से भी मर रहे हैं, पीछे वाले उससे देख रहे होगे, पीछे वाले साइड, पीछे वाले बाउंड्री से लोग मर रहे हैं। थोड़ा सा बल्ज दिख रहा होगा हल्का सा। हाँ, हाँ, तो चारों तरफ से लोग मरे जा रहे हैं, मासेकर हो रहे हैं यहाँ पर। लेकिन ये है 2D वाला। 3D वाला कैसे बनाता मैं? 3D वाला बनाता तो मेरे को एक और एक्सेस चाहिए होता 4D के लिए, तो 2D वाले में 3D, तो 4D वाले में पता नहीं क्या। तो वो छोड़ दिया मैं। और हाँ, ये अभी हम पहुंच चुके हैं तो मैं बहुत पास है। 1 घंटा 2 घंटे कितने हो गए? ये तो ये हो गया मैट लैब का। अब मैं कुछ शायद एक और चीज़ दिखाना था, लेकिन मैं भूल गया हूँ।